Okay, hello class. I'm off camera here tonight, but here's my little avatar, I guess, for Dr. J. I thought tonight we would talk about chapter three just a little bit. I have put up some review video for you from your principal's course. Um, Hope you view that. Primary topic here in chapter three is that of elasticity. So the idea here, of course, with I'll just say elasticity, just kind of make this brief a little bit. We would all know, for instance, if you had a 1 foot rod of steel, here's a 1 foot rod of steel, and here's a 1 foot rod of rubber. Uh, that rubber is more elastic than steel. What I mean by that is if you were to hang a weight off the end of each one of these of the same amount, maybe these are suspended from the ceiling. The idea is this, if it's rubber as opposed to steel, the rubber would stretch more than the steel. We all know that when you put the weight on there. And then when you take the weight off, it would restore itself to its original position. So, much more so than steel. So we say it's more elastic. Rubber's more elastic than steel. Now, there's a reason why I'm describing the topic of elasticity this way. This is a term that we have used before. When we talk about something elastic, we mean you can stretch it and then it'll restore itself and so forth. That is to say, there's a quantity here, in particular length here with these rods, that's more responsive to an applied force. So maybe this is a 1 kilogram mass you hang here on the end of this thing. It's going to stretch the rubber more than the steel. Okay, so we could we could apply the same concept in economics. Okay, we can look at how some quantities respond to a change in an applied force. Like instead of a mass here or weight, we might talk about a change in price. How does a change in price? So here's my question. How does a 1% change in the price of a good affect uh, uh, its quantity demanded in the marketplace? Okay. How does that would affect the quantity demanded? In other words, it could be that a 1% change in price would cause a 10% change in the quantity demanded. In which case we would compare these two just like we would here with elasticity. We would say a 1 kilogram mass causes a 10% change in the length here of a rod. Here it might only, for a steel rod, a 1 kilogram mass might have changed the length of this thing only by a tenth of a percent. Okay, so because this is more elastic. So you compare the change in the response variable to the change in the applied force. We're going to do the same thing here. When we write this thing here, we're going to look at the percent change in the quantity demanded that results from a percent change in the price of a good. And this we call elasticity. Uh, your your text uses the symbol E for this, and you're going to see this on page 76 of your book right here, that the elasticity of the price of good X, uh, and we call this the own price elasticity of a good X. The quantity is given this way. It's the percent change in the quantity demanded of X divided by the percent change in the price of X. So it's kind of hard to read these subscripts here, but basically this is the variable here that responds to a change in this variable. Okay, I kind of messed my thing up here just a little bit, but the idea here again is we write E sub Q X comma PX. So it's a change in the price affects a change in the quantity demanded of good X. And so it's going to be the ratio of the percent change in the quantity demanded of the good divided by the percent change in the price. Now, hopefully that formula looks familiar to you from your principles course or something like that. We try to be a little more precise at this level of study, and so we use these subscripts here. But typically speaking, in a principles level course, we might just write it this way. Okay, it means the same thing here. It's a very simple idea. Is we might say that a 1% change in the price of a good affects a 2% change in the quantity demanded. In that case, the elasticity would be 2 over 1. Okay, now here's one thing we note is that actually prices and quantities move, quantity demanded move in opposite directions. So if you raise the price by 1%, you'll decrease the quantity demanded by 2%. So typically in undergraduate courses, we make note of the fact that these two always move in opposite directions. This variable moves in oppositely of this variable. So this will always be a negative fraction because they'll have opposite signs. So since you know that, then a lot of times we'll strip the sign off. We'll just put absolute values around this. That strips this sign off. But in your text, I believe they do that kind of with this notation here at the top of page 77. They put absolute values around this. They'll note that then, okay, the own price elasticity can be greater than one or less than one or equal to one. Now, so uh, we talk about elastic goods and inelastic goods, price inelastic goods, and unitary elastic goods. And these kind of separate goods in these categories that determine how responsive then the quantity demanded of a good is related to its price. And so they compute some own price elasticities here at the bottom of page 77 for a particular good and so forth. Now, so I just want to mention this hopefully as a topic you've seen before. There are other elasticities. Okay, we can look at income elasticities and cross elasticities and so forth. I'll tell you what, let's go to the PowerPoint slides and I'll show you where these are in your reading. So let's see, share. Okay, here we go. So hopefully you can see this, okay? And I may make use of this here, this document camera as we proceed. But let's see here. We have, you have these slides available to you here. But again, the elasticity concepts to measure the responsiveness of one variable to changes in another variable, or the percent change of one variable that arises due to a given percentage change in another variable. And so that first formula there should look familiar to you. We just talked about that. Now, here's one reason I'm making this video is sometimes we get a little apoplectic when we use the little calculus here to accomplish the same thing. The letter D there, when we talk about dg, ds, this is a derivative. We've talked about derivatives just a little bit. You can also think of this as like a little delta here, delta G over delta S if you want. So, if you had delta G over delta S instead of dG over ds and multiply this by S over G, what you really have is something equivalent to delta G divided by G divided by delta S over S. You invert the denominator, multiply here. And so this is just basic mathematics here. Hopefully we understand that this is equal to this. And I'm saying that this expression they give you here on page I forget what page this is given to you on your book. In your book, it's like the very first page of this chapter. I guess that's page 76. They give you this as a formula for elasticity here on the left. You can replace the D with delta. It's kind of the same idea here. A derivative, recall, is the slope of a tangent line for a curve. And so we looked at that before. Here they got, basically they're saying that if you look at G uh, as a function of S, and then we can talk about the slope of a curve that would join 2 points on that curve. by this secant line, looking at delta G over delta S here with this little right triangle. This would form the hypotenuse. So the idea, I'm simply, if these 2 points are very close together, the secant line becomes a tangent line, and this is called a derivative, as you'll note from the first video that I produced. But if you zoom in with a microscope, we could use delta just as well here, separate those 2 points with a secant line here instead of a tangent line. And this should look familiar, or if written in this form, should look familiar to us from our uh, principles level course. Hope you can see this, okay, in the window there. Because what this is a percent change in G. The numerator is a percent change in G divided by the percent change in S. And that for sure is something that should look familiar to you from your principles level course. That's the first formula you have. And that's what you're going to have to be able to use in this course to work the problems, okay? But this is a handy formula as well for those who want to take a calculus shortcut to do some of these. The only thing you'll have to be able to differentiate is a polynomial, but that should be straightforward enough, as we've mentioned in a previous video. So I want to leave it at that for a minute. Important aspects of elasticity, really the expression inside the absolute values is generally going to be, when you're talking price elasticity, it's going to be a negative. So we put absolute values around it. And so it could either be greater than one or less than one. I wish I had a little more of a space here. If the price elasticity of demand is greater than one, we say that G is highly responsive to changes in price. So that would say that the percent change in the response variable, I'm not quite sure why your book uses G and S here. We typically talk about simply the price elasticity as being the percent change in the quantity demanded divided by the percent change in the price. And so if this fraction here has absolute value greater than one, it means the numerator is bigger than the denominator. We say that that's a highly responsive change to quantity demand is highly responsive to a change in price. And so that good is price elastic good. If the absolute value of the price elasticity of demand is between 0 and 1, that is to say this expression is less than 1, we're talking about an inelastic good. Okay, so there's different elasticities. We're going to focus initially on this one. So if you want to start kind of right here, that's this expression I have in this box here. This box is what you have here. It's percent change in the quantity demanded of X divided by the percent change in the price of Y. That's got to look familiar to you from your principles level course, okay? If it doesn't, review the videos that I post. All right. So related to that, there are several goods that we could mention here. I wish your book went into that a little bit. I guess this is table 3-2 here. Before we go to this table right here that's on the slide, I'm not sure. Let's see if I got this somewhere here. 3-2. I should have. You would think they would give us that, but they don't. I thought we did. So let's go back here just a second. We'll talk about this table 3-1 in a minute. Hopefully you can see table 3-2 in the camera here. It's in your book. But we have some own price elasticities for various goods here, and they left the negative sign on here. So you just got to judge from the context whether we keep the negative sign on or not. I just want you to be aware when you watch one of my videos from Principles Level course of microeconomics, I generally take these negatives off. We know they're all going to be negative because price and quantity demanded move in opposite directions. So at any rate, whole milk is pretty price elastic. We say it's a very elastic good because its price elasticity has an absolute value greater than one. So does steak, okay? And then tea. Look at this. Steak and tea are more luxury goods. So the quantity demand is going to be very responsive to a change in price, very high price elasticities. When you get to more necessities and so forth, like milk and meat and so forth, or something that's a small portion of your budget, like pepper, those are going to have small price elasticities of demand. So I mentioned that just a little bit in the principles level videos that I post. So you might want to watch those with some care. Okay, anyway, let's see here. Let's go back to the slides here. This again is the formula that should look familiar to you for price elasticity of demand in your principles level course. It's the percent change in the quantity demanded of X divided by the percent change in the Y in the price. Okay, so here we have quantity demanded is here's the demand function, 80 minus 2p of x. You should be able to plot that, by the way. Okay, this demand curve you see here. Let's see here. That should be easy enough. When they say quantity demanded is of x is equal to 80 minus 2p of x. Okay. Um, you know, I mentioned in class how you can use P and Q however you want here, but you can find the two intercepts of this demand curve. This is a demand curve, so it's going to slope down. So we could find these two intercepts here easily enough by selecting a value of 0 for one variable, say for Q, and finding the corresponding value for P and vice versa. So for instance, if P is 0, okay, this term drops out and Q would be 80, right? And then if Q is 0, then P would have to be 40. Does that make sense? So you put 0 in for one variable and solve for the other. So this is the price axis. This is the quantity axis. This is a demand curve. It slopes down. Well, what we're saying is that when Q is 0, so you're on the vertical axis, P is 40. Okay. So at a price of $40, there are 0 units that will be demanded. Alternatively, when Q is 80, that'll correspond to a price of 0. So if you lower the price all the way down to 0, there'll be 80 units demanded. This is the demand curve here. I think you see it has a slope here. Everywhere on this line, it has a slope of a -1/2. Okay, that's the slope. Okay, I'm going to make note of this. You usually use the letter M for slope. This is a slope of -1/2. Okay, so first off, we're just describing the demand curve. Now, you'll notice from this table, what they're saying is that depending on where you are on this demand curve, like the point A is at P equals to 0 and Q equals to 80. So this is point A, all right? And then they plot B, C, D, and so forth, all the way up to point I. So this is point I here. And so they got these various points here, okay, like A, B, C, and so forth, all the way up to point I here. And what they calculate here is the ohm price elasticity in the next to the last column. You see that here? Okay, what you see is the own price elasticity is going to vary as you move up and down the demand curve. Now, I'll talk about this as well in one of the videos, okay? Why is this the case? But the idea here is that really, when you are at a high price, okay, if you were up here somewhere, the total revenue would be given by this rectangle here. So let's say if you were talking about point H here, this would be point H. Notice that's the next to the last row here in this table. Notice it's very price elastic in this region. Up here, they tell you the price elasticity of demand is I'll just say just E for that, but it's 7.00. It's got a negative in front of it. But the point is, if you look at the absolute value, that's much greater than 1. Very price elastic good. And the point is that if you had a small change in price when you start at a very high price, like $35 for this particular good, then the quantity demanded is going to be pretty responsive. Okay. Um, if you lower the price of caviar or T-bone steak, then people want to buy more of it. Or if you raise the price, people are really turned off. So the point is, when you're talking about high price goods or you're very high on the demand curve, you're looking at like luxury items and so forth. then you're going to have a very high price elasticity of demand. That is to say, the quantity demanded is very responsive to a change in price. For notice here, if I just lowered the price a little bit, if I go from H to G, so this would be G here, and this would be $30. Notice that the quantity demanded, okay, so we're going to go from the next to the last row to the row right above that. Notice that the quantity demanded doubles. It goes from 10 to 20. You see that there in the middle column here? The quantity demanded, so if you'll look here in the camera here, the quantity demanded down here doubles when we simply lower the price by a small percentage, 5 out of 30. What's 5 out of 30? If you take 5 out of 30, uh, clear, you take 5 divided by 30. That is a 16% change, almost 17%. We're lowering the price by 17%. Okay. When you do that, that creates a doubling in the quantity demanded or 100% increase. Okay. 100% increase. So it's just kind of rough figures. But in this region right here, we see that the price elasticity of demand is pretty high in this region. Okay. Between these two prices right here. Now, the price elasticity of demand exactly at this point is 7.0. At point G, it looks like it's a -3 or something. So it's very elastic at high prices, not so elastic, price elastic at lower prices, and so forth. And what you see by looking at the next to the last column is that as you lower the price or move down the demand curve, the price elasticity of demand is going to decrease. So we'd be moving from point I down to point A. So you'd be going up this column here, okay? And so you see that the good is becoming less and less price elastic. Now, so if you're at low prices, the good is very price inelastic. So we could play the same game down here and so forth. Again, I make a video, I'm gonna post a video from just principles level courses why this should make sense. And I spend a little more time. I only have like just a few minutes to make this video here. Uh, but at any rate, watch that video and you get more of a conceptual idea as to why the price elasticity of demand will vary along the demand curve itself. Okay. But in any case, all right, let me just mention this. Going back to our formula here, if you will, here, this calculus perspective, if you want, the price elasticity of demand. Notice they write it in differential form. It's the derivative of Q with respect to P over Q. That's another way of writing this thing up here, as we just noted. Okay, and you could go through that idea again. The percent change in Q is delta Q over Q in the numerator. So, I mean, delta Q over Q divided by delta P over P. That should look familiar to you as an expression for price elasticity of demand. And we just kind of rearrange the Q and the P. We leave the Q on the bottom because it's in the bottom here in the numerator. But if you're in the denominator to the denominator, you bring the P up. And so you can write P over Q times delta Q over delta P, and that's this derivative here. Now, why did I mention that? Okay, I just want to mention that here in respect to also, if you look at the screen here, the formula they give you for this function right here, this for this demand curve, Q is 80 minus 2P. And so what we're saying here is this formula tells you how to find the price elasticity of demand. Just using a little basic calculus, the price elasticity of demand is equal to the derivative of Q over P. You can write a D this way or this way. It means the same thing, times P over Q. Okay. And so you find the derivative of P of Q with respect to P. And if you come back up here, you'll see that remember, if you differentiate a polynomial, that's simply this number right here. Derivative of 80 is 0. It's constant, but the derivative of the last term here is a -2. So this is a -2. Okay, it comes right here times P over Q. All right. So this would be a formula for the elasticity, price elasticity of demand, or own price elasticity of demand. Now, notice something here. When you move down the demand curve, okay, price goes down, but Q goes up. So as price goes down and Q goes up, this fraction gets smaller and smaller. Okay. So as it does, the price elasticity of demand decreases in absolute value. If this goes down and this goes up, this fraction goes down. And you can find the price elasticity of demand for any of these price quantity combinations, but you'll notice whether it be at I, H, G, or so forth, as you move down the demand curve, P is getting smaller and Q is getting larger. But you should be able to say for point D here, where the price is 15. Okay, so if the price is 15, I'm going to write this right here. If the price is 15, the quantity demanded is 50. If I put these two numbers in here, I should be able to find the price elasticity of demand. This is a negative 30 over 50, right? This is a negative 30 over 50. What's that? That is a negative 0.60. Okay, a negative 0.60. So looky here what's in the table. Okay, right over here, you'll see that value given here in the table. So we're just using this formula here. This is the derivative of Q, the demand function, with respect to P. So just strip that exponent or this coefficient off here. It's a negative 2, P over Q. And so this thing's going to change as you move down the demand curve. Okay. All right. But at any rate, I don't, that may be a little advanced for some of us, and that's okay. If you watch the videos, though, that I post, watch the part of the videos that I post up that I ask you to as a review of your principles level course, then you should be able to understand how we can draw these total revenue rectangles here that are inscribed within the demand curve and show that as you move down the demand curve, the percent change in Q divided by the percent change in P is that fraction is going to get smaller as you go down the demand curve. And so the elasticity approaches, well, it's going to approach a zero. It goes from negative infinity here at the top of the demand curve to zero at the bottom of the demand curve. Okay, so let's just run through the rest of this. I also have a video here. In fact, today I talked about this in my principles level course. I think that's the video I'll post here tonight that shows that when you plot total revenue, that's what you have on the vertical axis here in the second graph. Total revenue is a function of quantity that's demanded along a demand curve. So notice here again, this is just a demand curve at the top. It's elastic, has price elasticity greater than 1 at the top and less than 1 at the bottom, or between 0 and 1 at the bottom. It's inelastic down here. But the total revenue at each one of these prices is given by the area of the rectangle we can inscribe within this demand curve. So I drew some of these here, but at any rate, total revenue is price times quantity. That's length times width of each one of these rectangles. So for instance, you can take 35 times 10. That sounds like 350, right? At a price of $35, in which case you would demand 10 units, 10 quantity, a unit of 10 units in a day or a month, the total revenue is going to be $350 because that's the area of the rectangle that's inscribed here at point H. Should run through that exercise here and see how these rectangles get bigger as you approach a price equal to the midpoint. That for the midpoint of the demand curve, then the rectangles will get smaller again. So those total revenue rectangles grow in size until you approach the quantity that's midway between the two intercepts here on the demand curve. So this linear demand curve intersects the quantity axis at 80, which is to say then halfway there at a quantity of 40, you're going to get a maximum total revenue. Okay, so another thing I mentioned, and this again, I'm just trying to do a summary here tonight, but you should recognize that when you're talking about, you should recognize this from your principles level course, that when you have an elastic good, price and quantity demanded move in opposite directions. When you have an inelastic good, the price and quantity demanded move in the same direction. I said price and total revenue. I said quantity demanded, but price and total revenue move either in the same direction or opposite of each other. So when demand is elastic, price and total revenue move in opposite directions, okay? When demand is inelastic, price and total revenue move together. So for instance, down here, for an inelastic demand, a price increase corresponds to a total revenue increase. They move together, okay? But if demand, and so that would be the case, when you're low on the demand curve in the inelastic region here, price and total revenue are going to move together. We have to spend some time and think on that. We don't really have the time to chew on this much in this video, but I'm just mentioning some things here that I give a little more explanation for on my principles level courses. So I just want you to see that this is basically a theory you've seen before. When demand is elastic, you're way up here on the demand curve, say, at a high price, then a change in price will be the opposite to the change in total revenue. So if you increase the price in this region right here, then you're going to decrease the total revenue. Okay. Here are the extreme examples: perfectly elastic and perfectly inelastic demand. Again, this should look familiar from your principles level course. Just kind of running through this. Factors that affect the own price elasticity, the availability and number of substitutes. When you have a lot of substitutes for a particular good, expect it to be more price elastic. If there's much more time to make a change in purchasing, your purchasing behavior. I talk in class about how with gasoline, if the price of gasoline because of a war in the Middle East or something like that, where price were to double up essentially overnight. In the short run, the price elasticity is very low. People are locked into their commuting patterns to work and so forth. So if they wake up in the morning essentially and realize that the price of gasoline's risen by 50% or even doubled, they'll say, "Oh heck, I still got to go to work." So they're apt to buy close to the same amount of gasoline. But over a period of time, weeks, maybe a couple weeks or what have you, if the price of gasoline indeed has jumped significantly, they'll look for other ways to get back and forth to work. So that is to say the time or duration of the purchasing horizon has an effect on the price elasticity of demand. You want to use your common sense here, basically. Okay. So if you have a lot of time to look for a substitute, then the good will be more price elastic. So it all has to do with substitutes and can you find substitutes in the length of time that you will require before you make your next purchase. Also, expenditure share of a consumer's budget. That's why I mentioned pepper a while ago on this table of price elasticities. We noted that with pepper, okay, it was a pretty price inelastic did it. I don't see that here again, but go back and look at what page that was on. Here it is. Okay, notice the price elasticity is pretty small for pepper. Okay, so if pepper doubles overnight, you're still going to buy the same amount of pepper essentially. Why? It's not like gasoline. If the price of gasoline doubles or the price of your apartment rental doubles, you're going to be looking for something else. But if the price of pepper doubles, you're going to say, "What the heck?" Or table salt doubles, you're going to say, "What the heck? I'm still going to buy this stuff." Why? Because of this thing I have highlighted on the screen. It's a small share of your consumer's budget. So things that are a small share of your budget tend to be price inelastic. If it's a large share, again, like apartment rental, car payments, and so forth, then look for that to be a more of a price elastic good. Here's a little formula here we'll derive, I think, in chapter 8 that also can be used to show you how the marginal revenue is related to the price elasticity of demand. Uh, I don't think in this chapter I'll be assigning any problems with this formula yet, but you will be seeing this again in chapter 8. So I'm just going to skip over this. So again, here's the demand curve. In the upper regions, the good is going to be price elastic, and the lower regions is going to be price inelastic. I do mention, and in my discussion, especially on monopolies, and I show how in my principles level course, I show how the marginal revenue curve is beneath the demand curve. The same theory applies for this chapter in your course. Even though we're not strictly speaking only about monopolies, you'll want to note my discussion in that course about how if an individual supplier who is facing a downward sloping demand for their product, okay, that their marginal revenue curve will be beneath their demand curve. Again, in this short video, I don't want to go through all that, but I do what I think is a very thorough job. I did so today. I think I'll put that video up again here today for kind of a summary here. As in my course, my undergraduate course is talking about downward sloping demand curves like monopolies, downward sloping demand curves that face suppliers. And so again, we go back over this concept. So be sure and watch that if you would. Okay. Let's see here. You got cross elasticities, okay, or sometimes we call it cross price elasticities, where the price of or the quantity demanded of one good is affected by a change in the price of another good. So, gasoline and automobiles are complements. You have to have gasoline, unless it's an electric automobile, right? But you have to have gasoline to drive most automobiles. So they're complements. So when you have complements, like in the second case here, talking about the price of gasoline. If the price of gasoline goes up, the quantity demanded of luxury or gas guzzling automobiles is going to go down. So these move in opposite directions. If the price of gasoline goes up, the quantity demanded of gas guzzling automobiles will go down. So the cross elasticity of demand is negative here for complements. For substitutes, things that you use one in place of the other, bus tickets versus gasoline. Okay, there's a substitutes. There's two different ways to go to work. The price of gasoline goes up, and it could be then the price of bus tickets are going to go up because the company that run or the city or municipal authority that runs the bus realizes that they can charge more for a bus ticket if indeed the price of gasoline's gone up. So people got to get back and forth to work, right? So in that case, you got substitutes. If the price of one good goes up, the quantity demanded of the other good goes up, then you're talking about substitutes. Again, this is just a principles level concept. So they look at the cross elasticity of demand here, and they give you the cross elasticity of demand between clothing and food is a negative 0.8. Again, the sign here really is significant. If this is negative, then you're talking about complements. If it's positive, you're talking about substitutes. So here, food and clothing are considered to be complements. So it could be different theories as to why that's the case. You certainly have to have food to go buy clothes. You got to eat before you can go out and do much buying of things and so forth. So any rate, considered to be complements here. You might look at that in a little more detail, but they give us a value for the cross elasticity of demand. They talk about a 10% increase in the price of food. How does that affect the quantity demanded for clothing? So you simply solve for the numerator here, again, in this fraction that's back here. So this could be the unknown here when they give you a value for the left-hand side and for the denominator here. Okay, I hope that makes sense. You have other elasticities. You have income elasticities and so forth. Yeah, I think this is a plug and chug formula. Okay, they don't derive this in your book, but this is another formula for finding the cross elasticity of demand, which would be this thing right here for a firm that sells multiple products. I think I will dodge this for now in your course. I'm trying to make this course as manageable as I can. It's a little bit of an advanced text. This is not a difficult formula at all to use, but I think there are more important things for us to look at. So I'll just leave it at that for now. If you're interested, we can talk about it. Feel free to reach out to me, but I think we'll skip over that. So as far as using this kind of shortcut formula, if you will, you may say, well, that doesn't look any shorter than this one up here. Well, there's certain problems that you can, I guess, use this formula for here, and certain other problems that this formula is more adapted for. So what I'm saying here again is your homework problems will be kind of centered on using this formula here. So well, there it is. If you're interested, if you're not, you'll see it in the reading, but you can skip over it if you want. Okay. Uh, all right, so there's an application of that formula. Income elasticity of demand. As mentioned here, that's another elasticity, a percent change in quantity demanded divided by the percent change in income. So we use M for income. So if your income goes up and you want more of the good, you demand more of the good. That's a normal good. That's usually the case. Flat screen TVs and luxury items and so forth. The quantity demanded and your income goes in the same direction. But there are a few things that you'll say, you might decide, hey, I'll never buy any more of that if I ever get a raise. Okay. So maybe if you're in college, you'll say, I'll never buy ramen noodles again once I get a real job after college. That would be an inferior good. Okay. If your income goes up, you demand less of the good. So black and white televisions, compact cars, efficiency apartments, some generic drugs and so forth would be inferior goods. I want you to be aware of that. And they work a problem here working with the income elasticity of demand. It's a very simple idea. It looks like here, you have to determine whether it's by using the signs here, whether we have an inferior or normal good, and you're asked to solve for the numerator on the right-hand side. Should be very basic, okay? And then there's other elasticities, the cross advertising elasticity of demand. It's just another application of the cross price elasticity of demand. No big deal. Again, you should be able to understand this again in light of the little problem I did a while ago. If you look here in the camera here, just a second, we did this thing here. We said that if you take the derivative of Q with respect to P and multiply by P over Q, that'll give you the price elasticity of demand. That's what you're doing right here. I know they got Greek letters here and so forth, but alpha sub X is the derivative of Q with respect to P of X. So you just rip off that coefficient here, just like we did here. Okay. So if you understand that, that's okay. If you don't, well, you can just use the formula. But here is the derivative. That's alpha sub X. That's the derivative of quantity with respect to price of X. And then again, you got P over Q. So watch my finger here on the left. Okay. P over Q right here. P over Q. This is the derivative. That's the alpha sub X. And this is P over Q. Okay. Okay, so it gives you the own price elasticity and the cross price elasticity and income elasticity are found similarly. It's just you're going to these other terms here. So the alpha sub Y is, the derivative of Q with respect to the price of Y. Same idea. And then it's P of Y over Q of X and so forth. So that should make sense to you, okay? Just kind of cruising through this. So you should be able to work with that formula. This is just a plug and chug formula. This is a graduate level class, so at least you should be able to do that, I think. Uh, here is a application, kind of a typical homework kind of problem you'll encounter here with this theory we just looked at. Okay. Um, Log linear as well. Here, it's there's a shortcut here when you look at log linear demand curves. Some demand curves are made linear if you take the natural log of the terms. And the elasticities are easier to find. You just strip off the coefficients. I'll just be honest with you. Again, this is another concept here, another form that I realize for some of you it may be kind of scary. So this is not as important as what we were doing just a moment ago. with just a basic polynomial demand curve. You definitely have to work these kind of problems. I would expect you to handle those. This is a little more challenging. I realize that. Okay, let's cruise on through here. We're just about through these slides here. Here's that log linear again. I want you to read through this, but again, there's more points, more weight associated with your knowledge of this than there would be of the log linear format. Okay, I might put a bonus problem on a test or something from this theory. So I'm not saying anything for sure here. I'm just trying to let you know this. It's more important you work this problem than that you work this problem. Okay, but you should be able to understand them both. Okay, here they do a little regression analysis to come up with this demand function here at the bottom. Okay, so you got quantity as a function of price, and you'll see over here, these two coefficients right there. Doing a linear regression on Excel will given some inputs, say some points on a demand curve. Maybe you got points B and G and H or something. And there's more of a scatter plot, but you should be able to plot a demand curve given a few points. You should be able to find the least squares line or linear regression line, the line of best fit. So you realize you might have some, okay, again, you might have some a scatter plot of price quantity combinations here. Okay, so you got Q here and you got price here. And this is what you've observed over time, these various values of Q and P. So here's a high price and low quantity, and here's a low price and a high quantity. So the idea is find the line of best fit through there. Okay, that's what Excel will do for you. In this case, it's telling you in these two cells here I have highlighted that it is this line of best fit has the form Q equals 1631.47 minus 2.60p. So it has a vertical intercept here, and so forth that you can find equivalent. Actually, if you want to find the vertical intercept, you got to express the inverse demand. You got to express P in terms of Q, and that would put it in a form you could easily find the vertical intercept. But you should be able to do the same trick though that we did before to find the values at which this thing will intercept the axis on both points here. But you may or may not want to graph the line itself. Okay, you should be able to find these two intercept points again, as we did a while ago, by putting a value 0 in here, solve for P, and put a 0 in for P and solve for Q. I mean, this one I can do here. If P is 0, Q is 1631. Okay, so if P is 0, it means you're down here. Q is this point right here. I had to mark that out here, but this is 1631. So there's the vertical or the horizontal intercept here. And equivalently, if Q is 0, you find P, it would be 1631 over 2.6. I don't know what that is. That's like 600 or something. What is that? Okay, this is no big deal. All you have to do is put a 0 here and you solve for P. It's going to be 1631 over 2.6. 1631 divided by 2.6. That's 627. I was close, I guess. 627.3. 0.3 if you want. And that gives you the two intercepts here for this demand curve. At any rate, you can use that curve then to do various things. So you should be able, given a scatter plot, it's a plot of points, the P versus PQ combinations, ordered pairs, you should be able to find the line of best fit using Excel. So we've introduced Microsoft Excel for linear regression before. This is just an application of that. Very important. Before the course is over, you'll at least you'll need to be able to do what we are doing here. You'll need to be able to do some quantitative demand analysis. That would involve, for one thing, taking some historical values for P and Q and finding the demand curve that best fits through there. Okay, Microsoft Excel is a neat thing. they show you again how you can do this for linear demand or for non-linear, say the log linear demand function. Again, the first one is by far the more important one for us in this course. Okay, so that is chapter 3 in a nutshell. Again, you'll want to go back here and uh, look at the videos that I posted for my principles level course. And if you got any questions whatsoever, look up this guy here. This is Dr. J, and we can talk. Okay, but I guess I don't really have to make these videos here, but I want to. I want to kind of cover this thing in kind of a comprehensive form so that when you need to go back and review, you know what it is you are reviewing for. But the main thing you got to do in this chapter is read your text. Okay, so hopefully I've given you some information here that makes your text more readable. Okay, so reach out to me if you got any questions at all. This guy here is available to help you. We can Zoom or do a Teams conference meet about any day of the week, but you have to reach out to me. Again, this course will meet not this week, but next week on Wednesday night. Hope you have a good evening, and I'll talk to you later. Bye-bye.